Hi all, my name is Orestes Papakyriakopoulos, but the last name doesn't matter. So I'm happy to be here and to present you our work we're doing at the ethics team in Sony AI. And one of the projects we focus on are to develop considerations for the ethical development of speech datasets, recognition and not. And in this talk, I'm going to explain you how we think about the issue, and specific our aim is to, think of how we could assist ethical speech dataset creation. So how can we create best practices or guidelines that can help practitioners and researchers to better understand the scope of the dataset they want to create, to the properties it should have in order to be robust, not to discriminate, etc., the limits of the dataset that they will develop and where it should not be used for, but also to think about how we can encourage the creation of datasets that respect the data subjects, the work they put in there, but also to empower the user communities. And I'm going to go through a bit on of the problem that exists, like how speech-language technologies result in biases and harms, and then go through the results of a literature review we have done, based on which we have some conclusions about ethical considerations that should be made when developing speech datasets, and also conclude by presenting you some augmented datasets for speech datasets we are developing and are going to be released soon. So speech-language technologies concern multiple tasks. One of them is speech recognition, but it could be also speech synthesis, speech quality assessment, enhancement, denoising, accent recognition, and so on. And usually one of or a combination of these are combined in specific applications. For example, in virtual assistants, Alexa, Google Home, etc. are some applications. A very prominent application of speech-language technologies exists in call centers, or like online services or telephone services where we talk and the system recognizes us, a lot of times produces speech. But there are also other applications. For example, a lot of these technologies are used for literacy assessment or for actual communication systems like Stephen Hawking has been using in the real world, and Darth Vader in Star Wars. But also, like, we have new applications such as in generative AI, where lyrics or music is produced and so on. So what's the issue now with these technologies? So they generate biases. For example, a study of Konecki et al. Showed that commercial virtual assistants and speech recognition studies have disparate performance between populations of different races in the US. So actually, if individual was speaking African American vernacular English, the probability that the model will make an error or misrecognize what they said would be almost double compared to a white American individual. And this is what you can see on the upper left plot. And this was consistent in different systems. And generally, this race or a dialect, like African American vernacular English, is not the only category for which such disparities can be traced, but they can be related to gender, the accent somebody holds. Like, for example, me, all the services never understand my Greek English. But also dialects, age plays a big role, speaking styles, the voice pitch, but also a lot of times individuals have impairments that influence their speech, and they face a lower performance of these technologies based on them. This also happens usually because these group categories are not consciously taken into consideration when these systems are designed. So in the bottom plot, for example, you see the results of error rates for different individuals from different countries, and you can see like you have this dotted diagonal line that shows the average performance of the system that was trained on a whole data set, and you can see that for when the gender is female, the lines are above this dotted line, while the most male lines are on this dotted line. This means that the designers of the dataset did not consciously think to balance the data and have equal representation of female voices in the dataset, with the result the model to be more biased towards this direction. And okay, like usually speech recognition can be a low stakes environment, or speaker recognition and so on, but this bias can have actual implications when we think of where they are deployed. For example, a lot of these speech recognition tools are used now in healthcare to create the reports of patients at doctor offices. But speech language technologies have been used by companies who do hiring assessment based on machine learning. So the speech and how and the content of the speech was reviewed by SLT software, and there such biases can have an impact on who will get a job and who not. Another, for example, issue from the US is like a lot of times the phone calls of incarcerated individuals are surveilled, and there is key spotting there in order to decide how an incarcerated person will be treated by the authorities. So a misrecognition or a false inference of a model can have very negative consequences on individuals. And also, like in generative models, for example, specific populations that exist in the data set are going to be included in the generation of content, while other groups will be held in invisibility. So these technologies have consequences, and they can be very serious. So it is important when data sets are created and released, we think consciously about how we should create them in order to mitigate negative consequences. So there have been various initiatives towards inclusive speech-language technologies. For example, Mozilla is creating the Common Voice dataset, which is a very big project of diverse speech across the globe. Meta recently is releasing the Causal Conversations dataset, which is a fairness evaluation dataset on speech to assess the performance of speech models, while there are other attempts of researchers to do audits and discover how these biases are distributed, emerge, and how we can mitigate them. So our approach is to try and formulate ethical considerations that developers, researchers, and practitioners can follow to ensure that they can be more, that the data sets they create can be useful, but also not be inclusive and not discriminate individuals as much as possible. Now, how did we formulate this ethical consideration? So we did a very large literature review of 220 speech datasets, and you don't have to look all this image and all the sentences. The main point is like we looked at 3 different dimensions in the dataset: the diversity, like who is included in the dataset, qualitatively and quantitatively. That I mean like how many hours of speech, but also if there is an accent diversity or a dialect diversity in the dataset. Furthermore, if there are specific inclusion practices, like was there consent by the data subjects, was there specific license, what are the specific licensing terms in these datasets, and so on, as well as what privacy mechanisms have been implemented so that individuals' privacy is respected. And we did that literature review to understand what properties the existing datasets fulfill and what not, and to understand also what should ideally new datasets have. And we did the same by reviewing almost 180 research studies related to speech in order to uncover concrete issues that emerge in the process of creating speech language technologies, like in which cases do biases emerge, what are the best practices to include data subjects and communities in the development of the data sets, what are some downstream harms that emerge when SLTs are deployed in the real world, etc. And the first consideration that we make, and we believe that dataset creators should follow, is to make a situated data collection. What do I mean with situated? It means that it's something that needs to be decided based on the social context that an application will be deployed. For example, you might want to create a data set that it is global, so you might try to include as many languages as possible, but many times you want to create a data set that focuses in a low resource language, or to try create a data set that has information about people that come from specific regions that have specific dialects and so on. And you can see, for example, on the upper left, that in the literature review, we found that most datasets focus on languages, and there is need for researchers and practitioners to think more about the dialects and accents and speaking styles that individuals hold, so that the biases of these models are reduced. Furthermore, there is a need to define better the affected user groups and data subjects in order both to understand what should be included in the dataset, but also who is the user of the products. For example, in the datasets we reviewed, I think there were only 3 datasets that included non-binary gender in them. Furthermore, usually, like, if many cases there was no age diversity in the datasets, but even if it was, it might have been too bucketed, so stratified, and then can have, for example, very negative consequences to kids, because child speech changes from year to year. Like, my voice from 35 to 40 might be the same, more or less, but the kids from 1 to 2 and 2 to 3 and 3 to 4, etc., changes a lot. So models might have a much lower performance for that demographics. Furthermore, it is important to make considerations of the sociocultural proxies that are inserted in the dataset, and the technological limitations that exist among user populations. For example, background noise is a reason that a speech recognition technology will not recognize your voice, but background noise correlates highly with socioeconomic status. The lower economic status we have, the more probable it is that we live in an environment with noise. So automatically, populations from these communities are going to be discriminated. Furthermore, when we collect data, usually, like, we might not think that we will collect data from people who are tech savvy, so to say. They might know how to use a smartphone. They might know how to use a computer application that collects the data and so on. So automatically we neglect individuals who might have not have that ability to use the system. So when you collect the data, you need to think exactly what is information and I need, and also to how do I develop the structure so I can have the data from the populations I want data for. And equally similarly, somebody needs to think about the quantity of collected speech. Depending the use case is different if I want to create an evaluation data set or to create data that I will fine-tune a model, compared to if I want to develop a model from scratch. But also in terms of vocabulary diversity in the collected data, since if I don't have appropriate and representative data, then there are going to be a lot of distribution shift cases in the real world applications, and the models are going to have lower performance. Now, there is also need to do socio-technical design. Besides thinking the social context, it is that an application exists. It is important to think also the political consequences that the technology that we develop will have in the society and has also on the data subjects. For example, many open source data sets are developed because it is easy to find speech related to them, and a great example is like a lot of data sets use Bible as text to create speech recordings in different languages and communities. But not all communities hold the Christian religion, and that can result to what is called symbolic violence. You have very few resources for small communities and low research languages, and then they mediate a power and values that do not correspond actually to the ones that these populations hold. So we need to be conscious about that and think carefully what the texts and the content of the recordings includes in order to respect the values of the individuals and the data subjects. The same applies also when doing interviews. So open-ended interviews are valuable because you can have spontaneous speech, which is very important for these technologies to work well. And it is important to then make questions and leave the data subjects free when creating these recordings in order first to able to express themselves as they want to, in order to actually have very good vocabulary diversity in the data set, but also say things that relate to their community and themselves. And ideally, in the development of this dataset, it is good to include these communities directly in the dataset development, because then you can understand obstacles of limitations of your data collection practice, such as, for example, before with the issue of tech literacy, and perform actions there so that you actually are able to have a diverse enough dataset. Of course, know and think about where a model is going to be deployed, because the dataset, the training dataset should reflect the content that the use case, the content of the use case as well, in order to, again, not have the distribution shift error. Equally important, it is to respect the consent, to think about the consent, the privacy, and the respect of the data subject. So there is this issue that now we open the web, we download hundreds of tera of data, and we train our model, and we think that everything is fine. But actually, this leads to the violation of of individual rights. Individuals haven't given their consent. A lot of times, there are even trademark violations, like intellectual property right violations, and so on, but also it might lead that this model hold personal information that with adversarial attacks they can be revealed. So it is important to think about these things and implement safeguards that both protect the individuals who create the data set, but also the data subjects themselves. And that can be a clear consent form about how the data are going to be used, and what information is going to be disclosed about the data subject. A straightforward opt-out process for individual if they want to leave or exit the dataset, which today is very difficult to fairly compensate data subjects, and that's a thing that is going to be already started appearing in generative AI, where a lot of artists' data have been scraped from the web, and models actually rely on them to generate an artwork or generate music. So there needs to be appropriate mechanisms and an agreement that the data subjects are compensating. Equally, as I mentioned, the efficient reduction of the personally identifiable information, both in the recording and in the transcripts of the recordings. And ideally, in order to think about and ensure that these ethical and legal risks don't appear, that the data collection process passes through either an IRB from a university, but also private institutions very often have ethics boards, and it is important to work with them to think and shape the data collection process. And one of the biggest issues that the technologies face is not only what data are collected, but how these data are transcribed in speech. And usually, like, this could be through crowdsourcing or with other pre-trained models that they take the speech as input and generate captions. But this generates biases. Almost, I think there were studies that said 15% of the errors in models come from the fact that the transcriptions were not correct already in the dataset. So it is important to find annotators who have the same demographic distribution as the ones, as the data subjects, so that they are familiar to accents, dialects, speaking styles that speakers in the dataset have. It is important to have appropriate voting systems to resolve intercoder bias as much as possible, both when it concerns speech, but also the metadata in the dataset. Think about which information is important in a recording. Is it only the speech? Is it also the background noise? Is it specific ways an individual speaks? And that relates also to the robustness of a model that will be trained and the uses of the model that it will be trained on this data. And again, the actual real-world application of the technology. And equally similar, a very common issue in these technologies is that although we collect speech in a specific language, individuals very often with code switch, that means they will use a different language when they talk, and this is not taken consciously into consideration many times. So researchers and practitioners need to pay extra attention on it. And regardless how the data are collected and etc., we need to ensure that there is a benevolent model deployment. That means that there is a need to have licenses that define exactly the use cases that the dataset can be used, and restrictions of cases it cannot be used. Define exactly the scope of the dataset, and for example, a lot of cases such as emotion recognition or similar affective computing models have been criticized because they make physiognomic and pseudoscientific inferences. So it is important to define how the model should be used, in which cases, again, in order not to create biased models and harm individuals. And equally importantly, there is a need to have in detailed documentation for the dataset users to understand how the dataset was collected in order to understand if it is good for their application and their scope. And towards this end also, and based on the knowledge we have generated, we are currently creating augmented datasets for datasets, which is we are supplementing the original datasets for datasets by Gebru et al., which is a form to actually filled out with dataset properties so that limitations and gaps of datasets can be located, but also provide general information about the datasets that can be useful to further practitioners. And this work is done in collaboration with Anna Cho and Alison Koeneke from Cornell and other team members from Sony AI. Thank you very, very much.